Hello everyone, welcome back to ng.classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. Our today's topic is understanding quadrilaterals. We will discuss this one, but before that, let me help you to recall some concept from geometry. Here we are having two columns, figures and types. We have some figure and we have to match the following figure according to its proper types. Okay, so before starting the matching, what will be the name of the first one, what type of figure is second one, you must know what is curve, what is simple curve, what is closed curve. Okay, so what is curve? In mathematics, anything which you can draw in one go without taking off your pen from the paper. Okay, without taking off the pen from the paper, such figure is called curve. Is this a straight line is a curve or not? Yes, it's a curve in mathematics because we can draw this one without taking off the pen from the paper. So this is also a curve. Now what about simple curve? Any curve which will not cross itself is called simple curve. If you are drawing something like this and it's not crossing itself, such curve is called simple curve. What's the meaning of crossing? If you are drawing something like this, then see how it's crossing itself. This one is not a simple curve. It's a curve because we can draw it in one go, but not a simple curve. Okay. Now what about closed curve? Any curve whose starting point and end point is same, such curve is called closed curve. So whether this one is a closed curve or not? Yes, it's a closed curve. See, its starting point and end point is same. It's a closed curve. Now what about this 8 kind of figure? It's a closed curve or not? Yes, its starting point and end point is same. It's a closed curve, but not simple because it's crossing itself. Got it? Now let's start doing this one. See this first one. It's a curve, right? We can draw this one in one go. Now whether it's a simple curve or not, it's not crossing itself. So yeah, it's a simple curve. Now whether it's a closed curve or not. So starting point and end point is not same. So it's a simple curve but not closed. Check the options. Simple, closed curve, no. A closed curve that is not simple, no. Simple curve that is not closed. Yes, this one is a simple curve which is not closed. Okay. Now what about the second figure? Whether it's a simple curve or not? It's not a simple curve because we are having, like, it's crossing itself. We are having a point of intersection here. So it's not a simple curve. Which option will be correct? Option D, right? Not a simple. Now what about this third figure? A circle. So circle we can draw in one go, whose starting point and end point will be same, and it's not crossing itself. So it's a simple, close. Which option will be correct? A, right? Simple closed curve. So this one is simple closed curve. Now what about this 4? Whether it's a simple curve or not, we can draw this curve in one go. But we will get a point of intersection. Here it will cross itself. So this is not a simple curve. But starting point and end point is same. So it's a closed curve. So which option will be correct? Option B, right? A closed curve that is not simple. So this one here it will be option B. Now polygons. So a simple closed curve made up of only line segments are called polygons. So what's the criteria for polygon? If any curve is simple, closed and made up of only line segments, then we can say that curve is a polygon. And if it will not satisfy this three condition, then we will say it's not a polygon. So suppose I am taking one example. I am drawing one shape. Is this a polygon or not? So at first we'll check whether it's a simple curve or not. So what's the definition of simple curve? When a curve will not cross itself while drawing, then it's a simple curve. So I can draw it in one go without crossing myself. So yes, it's a simple curve. Whether it's a closed curve or not. So here starting point, if I am drawing like this, here, then here, then here, and then here. So my starting point and end point is same. So yes, it's a closed curve as well. Now what about line segment? Whether I have used just line segment or not? So yeah, I have used just line segment. This one, this one, this one, and this one. Okay. So it's a polygon. What about this shape? Whether it's a polygon or not. So let me check the first criteria, that is simple curve. So whether it's a simple curve or not, while drawing this one, I have not crossed myself. So yes, it's a simple curve. Now what about closed curve? So if I'll draw like this, start from here and then here, then like this and then. The starting point and end point is same. So yes, it's a closed curve as well. Now what about line segment? Whether I have used line segments or not? So yes, I have used only line segments. Okay. So this one is also a polygon. Now what about this shape? Whether it's a polygon or not. So what's the first criteria to become a polygon? It has to be simple curve. Whether it's a simple curve or not? No, it's not a simple curve. While drawing this one, I have crossed myself, or we got the point of intersection here. So this one is not a simple curve, which means first criteria is not getting fulfilled. No need to go ahead and check. Here only we can say it's not a polygon. Now classification or categorization of polygons. So according to the number of side or vertices, we categorize polygon in different groups. So if any polygon is having 3 sides or 3 vertices or 3 angles, we call it triangle. Tri means 3 and angles. Here this is a triangle which contains 3 vertices, 3 sides as well as 3 angles. Now if any polygon contains 4 vertices or 4 sides, it's called quadrilateral. This is what we are going to discuss in this whole chapter. Quadri means 4 and lateral means sides. So any polygon which contains 4 sides is called quadrilateral. If it's contains 5 sides, it is pentagon. If it's contains 6 sides, it's hexagon. If it contains 7 sides, it's heptagon. Or like this only, we have named each and every one. Now what's diagonal of any polygon? So a diagonal is a line segment connecting two non-consecutive vertices of a polygon. So suppose I am drawing a quadrilateral, a polygon with 4 sides. Here this one I am giving a name A, B, C, D. Now what is consecutive vertices of B? It's A and C. Okay, which is like After B, it's C, and before B, it's A. So these are consecutive vertices. What's consecutive vertices for C? It's D and B. So what is diagonal? Diagonal is a line segment connecting two non-consecutive vertices. So B and D are non-consecutive. If I will join them, this will be a diagonal. So we got BD as a diagonal. Now, can we get any other diagonal here? Yes, if we will connect this A with this C, these two vertices are non-consecutive. So connect it. This AC is also a diagonal of this polygon. Now let's check this triangle has a diagonal or not. It's also a polygon, right? A, B, C triangle. What is diagonal? When we will connect two non-consecutive vertices, then we will get a diagonal. Here, consecutive vertices of B is A and C. Which one is non-consecutive? There is no one. Similarly, for A, when you will find that whatever vertices we are having, both are consecutive. Here, we don't have non-consecutive vertices. So, triangle don't have any diagonal. Okay. Now, what is convex and concave polygon? So, suppose I am drawing a pentagon. Okay. A, B, C, D, E. Here, when we will draw diagonal or when we will connect two non-consecutive vertices like A and C, connect it, we got diagonal AC, which is lying in the interior of the polygon. It's lying inside the polygon. Or when you will draw any other diagonal, like just join this B with E, two non-consecutive vertices, BE. This diagonal is also lying in the interior of the polygon. Such polygon is called convex polygon, where the diagonal will always lie, whenever you will draw a diagonal, it will always lie inside the polygon. And for concave polygon, suppose I am taking this polygon A, B, C, D. Now draw a diagonal here. I am drawing AC diagonal. Okay. Now another diagonal we can get here as BD. Now see this BD, it's lying in the exterior part of the polygon. So this polygon is called concave polygon. What is convex polygon? A polygon in which we will draw a diagonal and that diagonal will lie inside the polygon. And what is concave polygon? When we will draw a diagonal in concave polygon, we will see any one diagonal or maybe more than one diagonal is lying outside, exterior of the polygon. Such polygon is concave polygon. Now, what is regular and irregular polygon? So, any polygon which is equiangular as well as equilateral, such polygon is called regular polygon. For example, suppose I am taking a square ABCD. So, all the angles of this square is same, that is 90 degree, right? As well as all the sides are also same, AB, BC, CD and DA. So, it is fulfilling the criteria, that is equiangular as well as equilateral. Okay. Now, what is irregular polygon? Exact opposite or exact reverse of regular will be irregular polygon. So, let's take one example, that is rectangle. Is this a regular polygon or irregular polygon? So rectangle ABCDs, all the angles are same, that is 90 degree. It's equiangular. But is it equilateral as well? No. Here AB is same as CD and side BC is same as AD. So all the sides are not same. It's not equilateral. So rectangle is a irregular polygon. Now quadrilaterals. You know any polygon which contain 4 sides, 4 lateral is called quadrilateral. Okay. Whether it's a square or rectangle, all are quadrilateral. A, B, C, D. Now, what's the sum of all the angles of the quadrilateral? It can be like this as well. Right? A, B, C, D. Okay? It can be like this. A, B, C, D. So these are quadrilateral. What's the sum of all the angles of quadrilateral? Here, just see carefully. I am taking this one. In this quadrilateral, what we can do? We can divide this quadrilateral in 2 parts by drawing a diagonal. And here we are getting 2 triangles. Triangle ABD and triangle BCD. These 2 triangles we are getting from here. Okay, we know the angle sum property of triangle, that is sum of all the angles of triangle, sum of all angles of triangle is equals to 180 degree, right? This one you know already. So if I have divided this quadrilateral in 2 parts where I am getting 2 triangles, so the sum of all the angles here for this triangle ABD will be 180 and the sum of all the angle of this triangle, that is BCD, it will be 180, right? Now what will be the sum of all the angles then? It will be 180 plus 180, that is 360 degree. We got angle sum property for quadrilateral. How we got? With the help of triangle. So sum of all angles of quadrilateral, any quadrilateral, okay, will be 360 degree. And this is the angle sum property for quadrilateral. Okay. Now we know what will be the angle sum property of a quadrilateral, or sum of all the interior angles of any quadrilateral. But what about other polygons, that is pentagon, hexagon or any other polygon? So the first figure is representing a triangle containing 3 sides. Second one is a quadrilateral containing 4 sides. Third one is a pentagon having 5 sides. After that, I have drawn a hexagon having 6 sides. Now, angle sum property for triangle, we know that it will be 180 degree, sum of all the interior angles. For quadrilateral, now only we discussed, since we can divide it in 2 equal triangles, that's why 2 into 180, that is 360. Now, pentagon, just divide it in triangles, draw diagonals. This one is the first triangle. So I have divided it in 3 triangles. So it will be 3 into 180. Right? After that, hexagon. Hexagon, divide it in triangles. I got how many triangles? 1, 2, 3, 4 triangles I got. So Angle sum property will be 4 into 180 for hexagon. Now what are we getting from here? We are getting angle sum property of any polygon. As well as we are getting a formula, that is, if any polygon contain 4 sides, the angle sum property we can take out like 4 minus 2 into 180. If any polygon contains 5 sides, I can write it as 5 minus 2 into 180. I got a relation between sides and angles of a polygon. If any polygon contains 6 sides, I can write 6 minus 2 into 180. So what we got? Angle sum property of any polygon is equals to number of sides minus 2 into 180, and that will give the total sum of interior angles. Now you know how to take out sum of interior angle of a polygon. Now here we will discuss what will be the sum of measure of exterior angle of a polygon. So suppose I have taken one polygon ABCD. Here angle 1, 2, 3, 4, 5, these are exterior angles. Now suppose I start moving from point A along this polygon. Okay. So from point A I have taken an angle, turn of angle 5 and then moving along AB. Now from B I have taken a turn and moving along BC. Now similarly I am moving along CD and then DE and then EA, and at last again now I am on point A. So what can I say? I have finished one complete revolution. I've started from point A and ended on point A. So total angle I have covered is 360 degree, right? One complete revolution means 360 degree. It means I have taken a turn of angle 1. At first you can take, I have taken a turn of angle 5, then 1, then 2, then 3, then 4, and all are 360 degree. So the sum of measure of all the exterior angle of any polygon will be 360 degree. Okay. Now different types of quadrilateral, a shape which contain 4 sides. So here trapezium, kite, parallelogram, these all are types of quadrilateral, and special kind of parallelogram we are having as a rhombus and rectangle. We'll discuss this quadrilaterals one by one in detail. Now at first trapezium. So what is trapezium? A trapezium is a convex quadrilateral with exactly one pair of opposite sides parallel. So it's a convex polygon or convex quadrilateral. Recall the concept of convex quadrilateral. When we will draw a diagonal, it will always lie in the interior of the polygon. Such polygon is a convex polygon. So a trapezium is a convex quadrilateral or polygon having exactly one pair of opposite sides parallel. So here AD and BC are parallel. And this AD and BC that is parallel, these are called bases of the trapezium, and AB and CD is the leg of the trapezium. So AB and CD, it's called legs of the trapezium, and AD and BC are bases. Now kite. Suppose this one is a kite PQRS. Here side PQ will be equals to side PS. This adjacent side will be equal, and side RQ or QR is same as side RS. When we will draw diagonal in this kite, it will intersect each other at right angle. So these are the properties of kite. Now another quadrilateral, that is parallelogram. So we are having parallelogram ABCD. Here this AD will be parallel to BC, as well as it will be equal in length. So AD and BC are equal in length, as well as AD is parallel to BC. Here similarly side AB and CD are same in length. AB and CD are same in length, as well as these two are parallel. And also the angle, like opposite angles, are same. So angle ABC and angle ADC, these two angles are same. And here angle BAD will be same as angle BCD. So opposite angles are also same. So what are the property of a parallelogram? Opposite side will be parallel as well as equal, and opposite angles are also same. When we will draw the diagonal, both the diagonal will bisect each other. It will divide it in two equal parts. Now rhombus. Rhombus is a special kind of parallelogram. So what's the property of parallelogram? Opposite sides are parallel as well as equal. So this AB is parallel to CD and this AD is parallel to BC. But for rhombus, all the sides are same. As well as opposite angles are also equal for rhombus. And this will be equals to this one, like parallelogram. So angle ADC, here angle ADC is same as angle ABC, and angle DAB is same as angle DCB. Okay. And now we'll solve few questions from NCERT. I have taken from exercise 3.1 question number 2A and B. So our question is, how many diagonals does each of the following figure have? Figure A is a convex quadrilateral and B is a regular hexagon. So let's solve A at first. A convex quadrilateral. Quadrilateral means a polygon containing four sides, and convex quadrilateral means whenever we will draw a diagonal, it will always lie in the interior of the quadrilateral. So such quadrilateral is called convex quadrilateral. I have drawn one convex quadrilateral. Here we will start drawing diagonal and then we'll see how many diagonals we are getting. So non-consecutive vertices we have to join. Let's join B with D. This one is the first diagonal BD, and let me check what else. Yes, from C, if I'll draw and will connect it to a two non-consecutive vertices, we'll get another diagonal. So join it. We got our second diagonal AC. Now I can't draw any other diagonal. So we got only two diagonal, that is BD and AC from a convex quadrilateral. So how many diagonals? I got two diagonals. This has given me two diagonals. Now number B. What will be the number of diagonal for a regular hexagon? What is regular hexagon? Hexagon means any polygon which contain 6 sides. And regular hexagon, regular polygon's definition, recall it, when a polygon is equiangular and equilateral. It means all the sides of this polygon as well as all the angles are same. Okay, that's called regular hexagon. Now here also we'll draw diagonal and we'll check how many diagonals we are getting. So start drawing. Suppose I'm starting from point A and joining all the non-consecutive vertices of A. So I can join A with C. Then I can join A with E. And also I can join A with D. So these three are diagonals. Now from F I will draw the diagonal, whatever possible. We'll connect all the non-consecutive vertices. So from F we can draw FB and FC and also FD. Now same thing we'll do from vertex E. So draw diagonal. I can connect E with A, which is already I have done. From E I can connect C. Let me connect it. From E, anything else? Yeah, I can connect B as well. Okay. Now anything else from E? No. Now let's do the same thing from D. From D, non-consecutive vertices are F, A and B. So F and A I am already having. Let me connect D with B. Anything else from D? No. From C, check it. Already I have joined all the non-consecutive vertices. Now count the number of diagonals from here. So I am having 3 red lines, that is 3 red diagonals. Then I am having 3 pink lines, 3 more diagonals. I am having 2 green lines, 2 diagonals, and at last I am having 1 blue from D. So how many diagonals we are having? 9 diagonals. Got it? Now another question. So our question is, find the angle measure x in the given figure. We are having a figure, a quadrilateral. In that figure, one interior angle is x. We have to find the value of x. Okay. So let's give it a name. A, B, C, D. We are having a quadrilateral ABCD where 2 angles are given, and here just see this rectangular angle. You know this is 90-degree, right? And we also know a straight line angle consists of 180-degree. This total, it's 180. So here also a straight line angle, if I'll take, it will be 180. Where exterior angle is 90-degree. So interior angle will be 90 only, right? If outside is 90, this one will also be 90 only. Then only the straight line angle it will make, and that will be 180-degree. Okay. So now we know 3 angles, 90-degree, 60-degree and 70-degree, and we have to find the 4th angle. One thing we know, that angle sum property of a quadrilateral is equals to 360-degree. So all the interior angle sum will be 360-degree. Just add it. Angle x plus 70-degree plus 60 plus 90 is equals to 360 according to angle sum property. So angle x will be 220, Sum of all these three is equals to 360. Now the value of x will be 360 minus 220, that is 140 degree. So simple, right? So our next question is, how many sides does a regular polygon have if each of its interior angle is 165 degree? Before solving this one, let's understand one concept. So we have discussed what will be the sum of measure of all the exterior angle of any polygon, and that we got as 360 degree, right? Now suppose here I have taken the same figure and each of its exterior angle I have taken as x degree. So can I write x plus x plus x plus x plus x 5 times x is equals to 360 degree, or the number of side into x is equals to 360 degree. We are having 5 sides here. It's pentagon and each angle, all the angles are same. So each angle I have taken x, and that will give the total exterior angle sum, that is 360 degree. This concept we are going to apply in our question. So here in our question we are having a regular polygon. What's regular polygon? Any polygon which is equiangular and equilateral have each of its interior angle 165 degree. If each of its interior angle is 165 degree, like this, then what will be the exterior angle? It will be 180 minus 165, right? And that will give 15 degree. So if each of its interior angle is 165 degree, then each of exterior angle will be 15 degree, which we got from here. Now we don't know the number of side, but we just now we found a relation, that is number of sides into exterior angle, if all are same, is equals to 360 degree. So if I am writing at the place of number of side as a n, and 360 by 15, then we are getting the value of n, or the number of side, as 24. And this is our answer. Now another question. The measure of two adjacent angles of a parallelogram are in ratio 3:2. Find the measure of each of the angle of parallelogram. So let's take the first angle as 3x. Angle A I am taking 3x, and angle B, that is adjacent to A, I am taking as 2x. So let angle A 3x and angle B 2x. From here we know the property of a parallelogram, that opposite angles are same. So if angle A is 3x, then angle C will also be 3x only. That's the property of parallelogram. And if angle B is 2x, angle D will also be 2x. So we know angle A, the sum of interior angles of parallelogram, it will be 360 degree, right? We have done for quadrilateral, and parallelogram is also a quadrilateral. So angle A plus angle B, then C and D, all will be 360 degree, which means 3x plus 2x, then again 3x plus 2x is equals to 360 degree, which means 3, 4, 5, 5, 5, 10x is equals to 360 degree and x is equals to 36 degree. So find the measure of each of the angle of the parallelogram. So angle A will be angle A will be 3x, which means 3 into 36. (108°). Angle B will be 2x, which means 2 into 36. That is 72°. Angle C is also 3x, which means 108. This one is also 108. And this one is also 72°. So we got the measurement of each and every angle. And now our last question, that is, the given figure HOPE is a parallelogram. Here we are having a figure HOPE, that's a parallelogram. Find the angle measures X, Y and Z. Here we need to find X, Y and Z and state the properties you use to find them. While finding X, Y and Z, whatever properties we have used, that also we need to mention. So at first just see this HO and PE. HO and EP or PE. Since this figure is a parallelogram, these two are parallel, right? And this one is the transversal line I can take. Okay. Now can I say this angle and this angle will be same? Why? Because two parallel lines are getting cutted by a transversal line and this two will be interior alternate angle. So angle EHP will be equals to angle HPO. This angle and this angle will be same. Here we need to mention the property alternate interior angle. Therefore angle Y, from here we got angle Y is equals to 40°. This one and this one I am saying same. So definitely angle Y will be 40°. We got Y. Now just take triangle PHO, where Y we got as a 40°. This one exterior angle is given as a 70°. So what will be interior angle? A straight line angle consists of 180°. So interior part will be 180 minus 70, right? Which means 110°. Angle POH is equals to 110°. From where I got straight line angle. Now triangle PHO, take this one. We know angle sum property of a triangle, that is sum of all the angles of a triangle will be 180°. So 40° plus 110° plus Z, angle Z is equals to 180, which will give the value of angle Z 180 minus 150, that is 30°. We got the value of Z as a 30°, right? Now we found Y, we found Z. Now we need to take out the value of X. So here also just see these two are parallel. This one and this one these two lines are parallel and angle Z will be same as this angle. Again, alternate interior angles property. So that angle HPE will also be 30 degree. From where I got alternate interior angle. Now again, angle sum property of a triangle. Now we will take triangle EHP. Add all the angles x plus 40 plus 30 is equals to 180, which will give the value of x as, which means 110 degree. Or we can simply take out like this. Since we are talking about parallelogram, if this one is 110 degree, the opposite angles are same for parallelogram. So the value of x will be 110 only. Okay? And that's our answer. We found the value of x, y and z. I hope the whole concept on quadrilaterals are clear to you. Thanks for watching.